We've got some fresh images of 3-Eye Atlas. A
3-Eye Atlas.
3-Eye Atlas.
3-Eye Atlas.
got 3-Eye Atlas up there.
A visitor from deep space named 3-Eye Atlas has been acting in ways that no known comet should. It changes when we talk about it. It shifts its chemistry after we analyze it. Every time scientists publish findings about its anomalies, the object seems to adjust, as if reacting to our curiosity. It's not fantasy. The data are real. And the more we look, the more unsettling the pattern becomes. Across observatories and space agencies, researchers have been forced to ask a question no one ever expected to take seriously. Could something out there be listening and answering? For decades, the search for extraterrestrial intelligence has assumed that communication would come through signals, radio waves, lasers, something deliberate and recognizable. But what if the first reply came not as a message, but as an object? Not a transmission, but a reaction. That idea, once dismissed as science fiction, now hovers uncomfortably close to serious conversation, thanks to one stubborn enigma gliding through the solar system at tens of thousands of kilometers per hour. 3-Eye Atlas doesn't just reflect sunlight, it reflects attention. When the object was first spotted in 2025, it was cataloged quickly, its hyperbolic orbit confirming it came from beyond our solar system. At first, it appeared unremarkable, until its chemical signature began rewriting itself before astronomers' eyes. The initial readings from the James Webb Space Telescope painted a dry portrait. Carbon dioxide dominated its coma, while water vapor, the lifeblood of most comets, was barely detectable. The CO2 to H2O ratio was the highest ever recorded, 8:1. Scientists scratched their heads, but before they could settle on an explanation, everything changed. Weeks later, NASA's Swift Observatory detected a sudden surge of hydroxyl gas, the byproduct of water, gushing from the comet at 40 kilograms per second. It was like watching a desert suddenly flood. At that distance from the sun, water ice shouldn't have been evaporating. Something had either cracked open or switched on. The timing, as always, was suspicious. The change came immediately after the scientific community and the media had focused on its dryness. And it didn't stop there. Spectrographs soon revealed another bizarre inconsistency. The object's coma contained nickel, but almost no iron. The two metals are cosmic siblings, created together in the same stellar forges and found in near identical proportions across the galaxy. Finding one without the other made no sense. Yet, after the anomaly was reported, the balance shifted again. Iron appeared. The ratio normalized. The corrections were too clean, too fast. Comets don't read headlines, but 3-Eye Atlas seemed to. That's when Harvard astrophysicist Avi Loeb, a figure both celebrated and controversial for his willingness to challenge convention, entered the discussion with a calculation that electrified the scientific community. Known for urging researchers to treat the search for extraterrestrial intelligence with the same rigor as any other branch of astrophysics, Loeb argued that 3-Eye Atlas demanded more than passive curiosity. He proposed a startling estimate. There was roughly a 1 in 3 chance that the object was not entirely natural. Not a comet, not an asteroid, but something engineered. The claim wasn't made lightly. It was grounded in the mounting inconsistencies that surrounded the object's chemistry, its near-perfect orbital alignment with the ecliptic, and its strange tendency to correct its composition following human observation. To Loeb, the odds weren't an act of speculation. They were an invitation to investigate. In interviews and papers, Loeb emphasized that his hypothesis was not a proclamation of alien visitation, but a statistical acknowledgement of uncertainty. He explained that when nature behaves in ways that defy our models, we must allow for possibilities beyond them. His reasoning was simple but provocative. If the probability of natural explanations dropped below a certain threshold, the artificial must be considered, not as fantasy, but as a legitimate scientific alternative. To him, the danger lay not in being wrong, but in refusing to ask the question. His stance reignited a debate that had been simmering beneath the surface of astrophysics for years, one that questioned whether humanity's greatest blind spot might be its own reluctance to recognize evidence that doesn't fit comfortably within what it already understands.
The data itself invited that discomfort. Even as its gases shifted, 3I Atlas showed no measurable acceleration, despite outbursts that should have nudged its path. Its orientation remained almost perfectly aligned with the ecliptic, the thin plane where planets orbit, a rarity for interstellar objects. Its composition evolved not randomly, but rhythmically, almost as if it were syncing to our discoveries. Some began to wonder if this was what communication might look like when done by a machine. Subtle, indirect, yet deliberate. A probe that speaks through chemistry instead of sound. It wasn't long before the speculation turned stranger still. In late summer, astronomers detected cyanide gas streaming from 3I Atlas in an intense, narrow jet aimed directly at the sun. Cyanide, a molecule that can both destroy and create life, is often seen in comets, but never like this. Its emission was unusually strong and appeared in bursts, brief, repeatable spikes separated by pauses. To most scientists, these fluctuations meant nothing, but to a few, they looked like something more, a pattern. When the spectral data were analyzed by Grok, an artificial intelligence model designed to process astrophysical information, it reportedly identified the emission intervals as potentially modulated, resembling an intentional signal. Nobody asked the AI to look for communication, it simply drew that inference from the data. The suggestion was extraordinary and unsettling. Could 3I Atlas be emitting pulses of cyanide gas as a kind of binary code, using chemistry as language? If so, the implications were staggering. The emissions were strongest at wavelengths easily detectable by human instruments, as if designed to be seen. The bursts could represent an acknowledgement, a testing of our awareness, or even a symbolic introduction. Cyanide itself is a prebiotic molecule, the same compound that once helped shape the chemistry of early life on Earth. If someone wanted to say, "We understand life," this would be a poetic way to say it. Avi Loeb, meanwhile, expanded on another pattern that had gone largely unnoticed, the apparent timing of these changes. Each compositional shift followed announcements about the object's anomalies, press releases, journal papers, viral headlines. It was as though 3I Atlas were monitoring our chatter, adapting its emissions as feedback. He called it a feedback loop between observation and object. Others called it coincidence, but everyone agreed something about 3I Atlas was deeply wrong or deeply extraordinary. To skeptics, this could all be physics. A deeply fractured nucleus might vent in unpredictable ways. Thermal cracks could expose new layers of volatile material, causing abrupt shifts in composition. Cyanide bursts could arise from uneven heating or photochemical reactions, but even those explanations strain credibility when stacked together. The water outburst with no thrust, the nickel-iron inversion, the cyanide plume facing the sun. Each one improbable. All of them together? Nearly impossible. Loeb argued that the simplest way to test the theory was to watch for non-gravitational acceleration as the object neared the sun. If it adjusted its trajectory intentionally, stabilizing itself, for instance, that would indicate control. But as of its approach in October 2025, its path remained eerily stable, as though something were compensating for the very forces that should have moved it. The closer 3I Atlas came, the more intense the attention grew. Every night, new observatories joined the hunt, their instruments tuned to track a visitor that refused to behave. Mars orbiters redirected their spectrometers and cameras toward it, capturing streams of ultraviolet and infrared data as the object crossed their field of view. On Earth, the European Southern Observatory's Very Large Telescope in Chile recorded spectra that shifted in real time. Carbon compounds waxing and waning, metallic signatures rising and fading like the rhythm of a living pulse. Other ground-based observatories noticed something even stranger. The comet's tail, usually a predictable stream of gas and dust blown by the solar wind, seemed to breathe. It would brighten dramatically over several hours, then dim to near invisibility, only to flare again the next day. These cycles were not random. They followed intervals that didn't match its rotation or orbital period. To some researchers, it looked almost deliberate, as if the object were controlling its energy output in timed pulses. Scientists tried to model the phenomenon using standard comet physics, sublimation rates, albedo variations, rotational heating, but nothing fit neatly. The temperature data from the Infrared Facility Telescope showed no consistent explanation. Certain areas of the surface grew hotter than solar exposure alone could account for, while others cooled too quickly. The comet seemed to be redistributing heat across its surface in a way that resembled active thermal regulation, a mechanism more akin to engineering than nature.
At this point, speculation fractured into two camps. The cautious majority insisted on natural explanations, however exotic, but a growing minority, physicists, chemists, and data scientists, found themselves quietly entertaining a more radical possibility, that 3I Atlas might be an emissary, a constructed object disguised as a comet, now testing whether its observers were capable of recognizing intention when they saw it. The theory went like this. Once the object detected electromagnetic noise from Earth, our radio signals, radar, and telescope transmissions, it began monitoring us. When it registered increased observation or conversation about its anomalies, it adjusted its behavior accordingly. By tweaking its chemistry, it could both demonstrate awareness and test our ability to perceive patterns in natural chaos. A silent intelligence experiment on a cosmic scale. Such an idea sounds fantastical, but history is full of paradigm shifts that began as impossibilities. Electricity, germ theory, quantum mechanics. Each challenged the boundaries of belief until the evidence made disbelief untenable. Perhaps 3I Atlas is doing the same, forcing us to reconsider what communication might look like in a universe where we are not alone. And if it is communicating, it's doing so in the most profound way possible, by making us doubt our assumptions, by compelling us to listen more closely, by showing that awareness might express itself not through words or signals, but through reaction. Because that's what this object does best. It reacts. As October 29, 2025 approaches, the day of its closest approach to the Sun, the world's instruments are locked on target. From Earth's deserts to orbiting observatories, an invisible web of telescopes now follows the faint glimmer of 3I Atlas as it dives inward. Every major facility, from the James Webb Space Telescope to the European Southern Observatory's VLT and NASA's SWIFT and NEOWISE missions, has scheduled dedicated observation windows. The goal is simple but profound: to witness what happens when an interstellar body forged under alien skies faces the full intensity of our Sun. No one knows how it will react. Some predict that it will flare violently, venting its last gases in a final dazzling burst before breaking apart. Others expect a slow unraveling, its nucleus cracking, bleeding vapor into a widening halo that dissipates into silence. And then there are those, quietly hoping for, something else entirely. A change in trajectory, a sudden pulse of light, a signal hidden in the noise. Scientists are preparing for every possibility. Teams at NASA's Goddard Space Flight Center have developed real-time telemetry models to monitor non-gravitational motion to the millimeter. Spectrometers will record the smallest changes in emission lines, looking for any hint of controlled reaction, whether from sublimating ice or something that defies natural explanation. Engineers are focused on precision, coordinating simultaneous tracking between orbiters around Mars and probes near the Lagrange points to triangulate the object's motion. If 3I Atlas deviates even slightly, they'll know within minutes. But beyond the instrumentation and the data streams, there's another kind of anticipation, a collective tension that hums beneath the surface of science itself. For many astronomers, this is more than an experiment. It's an encounter. They are watching not just for what 3I Atlas does, but for what it means. Perhaps communication with another intelligence wouldn't begin with a message at all. Perhaps it would begin like this, with curiosity, with doubt, and with the unmistakable feeling that something, somewhere, has started to listen back. It's possible that 3I Atlas will pass the sun and continue outward, never revealing its secret. But if its changes are not random, if each shift is a response, then we may already be in the middle of our first dialogue with something beyond Earth. And that realization, whether confirmed or not, changes everything.